So, good afternoon, everyone. Welcome to lecture 12 uh, on the course Data Structure and Algorithm. Today, our topic will be on doubly linked list. So, in the previous class, we discussed about insertion at beginning and insertion at end of a node on a single linked list. But as per the lab scenario, so we are skipping insertion at intermediate position, delete operation, and display operation on single linked list. So let's start the topic insertion at beginning of a node on double linked list. So I'm sharing my screen. So hope you can see my screen. So is my screen visible to all of you?
Yes.
Yes.
Okay.
Yes, sir.
Right. Okay. So already you know what is a single linked list. So double linked list is another kind of a linked list which is having its own scheme. What is the scheme? So it is very similar to single linked list. Just one extra difference is there. That is like this. So let me draw a schematic diagram of a typical example of a double linked list. So I'm considering three elements. Or three nodes of this list. What is a linked list? It's nothing but a list where some components, some elements are connected by some means, by some rule. Okay, so this is called a linked list. In array you can say it's a kind of a, it's not actually a linked list, but in array also the memory locations are continuous, already connected with each other, one after another. But here you have to establish the connection. Okay, so for this is one physical entity. It is it is allocated with some memory. In some memory location, it is present. At some different memory location, this overall element is present. Another in different memory location, this element is present. So these memory locations are not contiguous in general; those are discrete, scattered manner. Those are memory locations are, and you are some way connecting those memory locations. In those memory locations you have stored some kind of element. In this case these are nothing but structures, some kind of structure, linked list, single linked list kind of node structure, double linked list based node structure, circular linked list based node structure, tree related vertex structure. Okay, graph related, sorry, tree related node structure, graph related vertex structure. Those are different structures. Those structures are present, are stored at some discrete memory locations, and you are connecting those memory locations with some rule. Okay, by applying some rule. So single linked list is having some rule. Okay, double linked list is having its own rule. So we are supposed to study what is the scheme, what are the rules of double linked list, and how it looks like. So in this case, these are nodes. I have drawn three nodes. This is how these are how nodes in a double linked list look like, and you can see each of these nodes are containing three parts. This is one part, middle part, right hand part. Similarly, left hand, middle, right part, left, middle, and right part. So this left part is nothing but a linker part, as similar to linked list, single linked list. You have seen in single linked list, it is containing two parts. This is the data part, this is the linker part. Linker part is nothing but a pointer which is supposed to hold some address of next node. Similarly, this is a linker part. Okay, it is supposed to hold some address of its previous node. Similarly, this is another linker part which is supposed to hold some address. It's a pointer. Pointer always stores an address. So this linker part is nothing but a pointer. This pointer holds an address of next node. And the middle part is the data part, which contains some information, data, integer data, float data, char data, array data, linked list data, file data, anything, structured data. Okay. Similarly, this is the linker part, data part, linker part, linker part, data part, linker part. So each of this node contains two linker parts, one data part. So I can define this kind of node in a double linked list in this way. Struct is a keyword. It's going to be a structure because it contains three parts, and these three parts are not of same data type. And you have already known array, where elements in an array must be of same data type. If you want to store data of different data types in a single entity, that is known as structure. So these nodes are nothing but structure. And struct keyword, then space. I want to give some name to the node of this structure template. Let's say DLL node, double linked list node, then this, then this. And first part is a linker part. And okay, so it's a pointer. So pointer declaration star, the name of the pointer. So it is going to point towards the previous node. So let me give it a name, prev. Semicolon. Oh, sorry. So next middle part is the data part. So let's say just declaration. I'm giving a name of that data part as simple data. This is the variable. And if I want this data to be an integer variable so that I can store only integer value over there, then it is declared as int data. And the third part is another linker part, which is nothing but a pointer. So you have to declare a pointer like this within using this syntax, the star, then give the name of the pointer, and this is pointing towards the next node. So I'm giving the name to this pointer as next. Now it's about data type of this previous prev pointer, data type of this next pointer. So these pointers are supposed to point towards other nodes, previous or next. So those nodes are having data type struct DLL node. So accordingly, the data type of this pointer becomes struct DLL node. Similarly, the data type of this node next pointer is also struct DLL node together. Okay, so this is how we can define the template of a node in double linked list. This is the code. Now, what we want? So let's say initially we want to introduce a pointer. That pointer is known as, its name is first. So how can I declare that first pointer using the syntax that struct DLL node star? It's a pointer, and the syntax of declaring a pointer is data type, then star, then name of the pointer. So the data type is struct DLL node, and then space, then star, then name of the pointer, which is fast. So this fast is supposed to point towards the first node always. Okay, present in the double linked list. Okay, so initially fast is pointing towards nothing. Let's say the double linked list is empty, so it is pointing towards null. Okay, so now let's say we come to the point. Am I audible?
Yes,
Yes,
sir.
sir, you are audible.
Yes, sir.
Yes.
So now initially linked list is empty, and we want to add a new node into the list, and that is going to be your first node, last node. Okay, So how should we do that? So I can start with the algorithm here. So algorithm. So initially, what we have to do that, okay, uh, first uh, this template definition is done. Struct DLL node star first is done. So you are reading from the user. Okay, what should be the value to be stored inside a data part? Initially, the linked list is empty, and you want to add a node. So first, what you have to create a blank node like this, which will contain which and of which structure will be like this. That means if the node structure of this node is like this, then it should contain three parts. This is the brief pointer, this is the next pointer, and this is the data part of this entire new node created. What should be the value you want to store inside this data part? This is data part, this is brief, and this is next pointer. Okay, but these two pointers are supposed to hold some addresses. Okay, and this is the data part where I want to store some integer data. So what integer data I want to store there, that value let me ask the user to provide. So read, let's say val, this val stores the data value to be stored inside data part of newly created. Okay, so this is the thing. So read val. So next, what I want, that I want to call a function insert at big, and see, this is the name of the function, no space, continuously I have written. And name of a function cannot include a space, comma, any special character other than underscore. You may also do this underscore, this is valid. Other than underscore, no special character is allowed in writing the name of a function, name or variable name. Also, it can't start with a digit, numeric, okay, to something like that. But it can start with an underscore, no issue. So insert at break, when first bracket start, you may give a space, not give a space, no issue. And there I want to provide the argument val. That information I have to send to the function definition so that it can use the value inside val to store it inside the data part of the newly created node. So this is the function call. So next, I have called this function. Next, somewhere you are defining the function definition. Insert, add, break, val. This is algorithm, not code. Okay. So here I am going to start the insert at break function. Okay. So initially, what is happening? I want to use a pointer, because whenever you want to create a new node, some pointer should hold the address of this overall node, right? And who is going to be that pointer? Let's say I'm giving that name of that pointer is temp. Okay, so this temp should store the address of newly created node. Okay, newly created node, this temp, so that it is pointing towards this newly created. So first step is you have to, step one, that is you have to create a blank load like this, of which structure definition will be this. Okay, so first is create a blank node. Okay, means do memory allocation for a blank node of start DLL node type and make it pointed by temp pointer. This is what I want in the first step. Okay, fine. So how can I do this? I'm writing the code temp equal to, okay, not writing the code. This is the step. Next, step 2. What is step 2? So this is done. This is the picture is done. And let's say its address is, some address is there. Let's say address of this overall node is, let's say 2000. Immediately here 2000 will be stored inside temp. The name of this pointer is temp and the value inside it is 2000, which is nothing but the address of this newly created node. So prev is storing nothing, data part is also storing nothing, blank, next pointer is also storing nothing, blank. So if I want to store, add this newly created node at the beginning position of the linked list, then this node is going to be the new first node. Okay, and so far we have understood this, right? Now let me show you a typical example of a double linked list. So if I do some connection, let's say, let me assign some value. It is storing some value 10, it is 6, it is 8. Before this node, there is no previous node, so it is pointing towards null. After this node, there is no node, so it is pointing towards null. This pointer is pointing towards this node. This pointer is pointing towards this node. This pointer is pointing towards this node, overall node, and this pointer is pointing towards this overall node. Okay, so this is the picture of a double linked list example containing 3 nodes. Okay, so if I assume that its address is 100, its address is 200, and its address is 300, then I should write here 200. Because it is pointing towards the next node, its address is 200. So here 200 should be placed. Similarly, here it should be 100, because this brief pointer is supposed to point towards this node. So it must hold the address of this node, which is 100. Similarly, you tell me what should be the address to be stored over here, because
That's
this pointer
300.
is going to point towards the next node.
300.
So this is
300.
300. Similarly, this should hold the address Any other person?
200.
200. Right. So this is the picture will be looking like. Okay. So now, if this node, suppose you have already three nodes, and this newly created node you are going to, and what is first in this case? Okay, suppose this is the example, and then first, the job of first is to point towards this node. That means its value inside this first pointer, its value should be 100. It is holding the address of the first node. That is the job of first pointer. Now at this situation, if I want to add a new node like this, of which address is 2000, but inserted at the beginning. So what should be the connection required like this? So first, this should be your new pointer, this node should be your new first node. Before its insertion, this node was the first node. But after insertion at beginning of this node, this is going to be your new first node. So first will no longer point towards this. First should point towards this node. And this pref should point towards null. There is no node to the left to the previous of this node, right? And this next pointer should point towards this node. So this is your first node, second node, third node, fourth node. And here you want to assign some value, store some user given value. Let's say 10. So these red colors should be done to successfully insert this node at the beginning position in an existing linked list. Existing linked list means already there exists at least one node. Okay, this red connections, red portions you have to do. You have to do. Sorry, you have to do. Okay, so how to do this? One by one. Okay, let me not delete it. Okay, so step number 2 is already you created a blank node. Step number 2 is, as this is going to be your new first node, so you are very sure, 100% sure that its pref pointer must point towards null. So pref pointer of temp, okay, temp means temp is pointing towards this node. What is the name of this node? Nothing, I don't know of name of this node, but who is pointing towards this node? Temp. So this, how can I access this pref pointer? Pref part.
So temp pointing pref equals to null.
Right. So if I want to access this part using temp, that can be done. This can be accessed. Also, this can be accessed. Also, this third next pointer part can also be accessed. How? Their syntax is temp pointing pref. This is temp pointing data, and this is temp pointing next. Okay, so in this manner we can access inside, okay, of this newly created node using tip point. So pref pointer of temp. So you know these are four different things. Temp is something else. Temp is holding the address 2000. Temp pointing pref means what is the value stored over here. That is the value of temp pointing pref. Temp pointing data means what is the value stored over here. Okay, in this case, let's say 10. So 10 is the value of this variable, temp pointing data. Okay, similarly, what is temp pointing next? Whatever address is stored over here, that is actually this temp pointing next. So these four things are entirely different. Okay. So pre-pointing of temp, pre-pointer of temp means temp pointing previous must be assigned null, right? So that it is pointing towards this red connection, this red connection. Okay. Next step, what is the step number 3? Once I am done with the algorithm, I can blindly do the code. It will hardly take few 10-15 minutes. So step 3 means this is done, this is done. Next, assign the value in the middle part, this data part. So data part of temp must be assigned val. Val is equal to 10. That val is coming as an argument through the function call and function definition. Okay, so this is then next done. Then step number 4. Step number 4. What should be the content inside temp pointing next? Next pointer of temp. So next pointer of temp must be assigned what? So it should hold the address, some address such that this red connection is established. It is pointing towards what? This node, the first node before insertion. Address of this node. See, if I store the address of this node here, then this red connection will be established. So who is storing the address of this node?
So first,
So that's why its address is 100, and you don't know what is the address 100. First knows the address of this node is 100. So this should be assigned first. Okay. Then step 5. What we have done so far? This red is done. This red is done. This red is done. Now you have to break this green colored connection and make this red colored connection. So I have to replace the content. I have to delete this content and replace it by something else. What is that? First should point towards this newly created node. That means first should hold the address of newly created node. So what is the address of this newly created node? 2000.
10.
Who knows that? Temp. Temp knows that the address of this newly created node is 2000. So this value of temp should be replacing the value of first. So first should be assigned temp. Then all the red color tasks will be completed. So this algorithm will be working very fine if already there exists at least one node in the doubly linked list. But you have to, but this is not proper, will not properly work if your doubly linked list is empty. Let's see if it is not working, now how to make it work. What final adjustment we have to do. Okay, so I already told you that it will be working when, so you will check a condition. If list is non-empty, then you will do this. Then you do this. This step, 5 steps. Okay, and then at the last, you do end if. Exactly. Okay, 5 steps. So let's see if there was no node at all in the list, then why this algorithm is not working. Let's see. Initially, okay. Suppose this is not there. So already we understood. So I'm erasing these connections. So first is pointing towards nothing. Its content is 0. Why? Because point first is pointing towards null. So this is our situation. And let's try to run this algorithm to verify whether it is working for this case also. So first step is, okay, read val, it is done. You are calling a function insert at base val, then then function definition, it is coming to function definition. If let's say this is not there, suppose I am commenting this is not there. Okay. So now at this situation, after function definition, it is going inside the function definition and it is seeing that step number 1 is create a blank node of struct DLM node type and make it pointed by temp pointer. That means this is done. A blank node is being created. Temp is pointing towards that because it is holding the address of this node, which is 2000 for our case. So this part is accessible by temp pointing brief. This data part is accessible by temp pointing data. This next pointer part is accessible by temp pointing next. This is step 1 done. Next, step 2. Brief pointer of temp must be assigned null. Okay, so it is assigned null and it is holding the address, let's say 0. Then data part of temp must be assigned val, let's say some value 10. That is also done. Step 4. Next pointer of temp must be assigned first. What is first? 0. So it should be assigned 0. That means this is pointing towards null. So initially, if there was no single node in the double linked list, this is going to be the only node, and then it's brief. To the left of this node, there is no node, so it is pointing towards null. To the right of this node, there is no node, so it is pointing towards null. Next pointer is also pointing towards null. And this should be the picture. Yes, of course, this should be the picture and is correct up to step 4. But in step 5, what is there? First must be assigned first must be assigned temp. So for temp is 2000. So here it should be 2000, so that this connection is lost and this is pointing towards this. Okay. Okay. Am I correct?
Yes, sir.
Is okay?
Yes, sir.
Okay. So one thing, now I will show you why this algorithm is not working properly. One thing I have skipped, that is this. Again, I am one thing I have skipped actually, that's why. Okay. So let's say it is pointing towards 100. Let me bring the previous situation where already there are 3 nodes. I forgot one thing, one connection. That's why it's a problem. So prev is pointing towards null. Next is pointing towards this node. This is holding some value, let's say 10. This connection you are breaking, first is pointing towards this node. Another step 6 should be there, that is this connection. This pointer should not point towards null after adding this node at the beginning. This connection you want to break, you have to break, and this pointer should point towards this node as per the scheme of doubly linked list. Okay, this is the prev pointer of this node, and it is supposed to point towards its previous node. So if this is the new node at the beginning, then this prev pointer must point towards its previous node, which is this one. Okay, so there should be a step 6.
Sir,
Which is prev pointer. Let me write it. The prev pointer of first. Okay, so before it we have to do this.
सर पहले तो फास्ट पॉइंटिंग प्रीव इक्वल्स टू टेम्प होगा पहले तो
Yes.
सही
So prev pointer of fast. Prev pointer of fast. Prev fast is what? It is holding towards address before this connection, before this red connection, before this red connection. This was the scenario. Step 1, step 2, step 3, and step 4. The blank creation, blank node creation is step 1. This is step 2. This is step 2. This is step 3. This is step 4. And now step 5. Step 5 means you want to have this red connection, this connection. How can I do this? And you want to break this connection. If you want to do this connection, automatically this connection will be lost. Okay, so how can I do that? So this prev should hold the address of this node. What is that? 2000. So here I must assign 2000. So prev pointer of fast must be assigned address of new node, that is temp. Okay, so if I do this, then this red color connection will be established. And this connection will be lost, right? And then in step 6, you have to break this connection and you have to establish this connection, because fast is going to point towards this new fast, and that is already written, has been written. Fast must be assigned 10. So this is the algorithm to insert a new node. Okay, at the beginning, when there is at least one node in the double list. Okay, so you must understand again, step 6 can't be done before step 5. This should be step 5, this should be 6. Because if you do step 6 before step 5, fast will be altered. This green color connection will be lost, then it will be totally changed. So it's a sequential thing. You know, C language is sequential. So sequentially you have to do these events, right? Otherwise it will be a problem. Okay, now let's come to the situation when doubly linked list is empty. So let me delete this connection, fast connection. Okay. So fast is pointing towards nothing, means null. Okay. Okay. So first step, creation of a blank node. Second step, brief pointer of temp must be assigned null. 2 is done. 3 data parts temp 3 is done. Step 4, next pointer of temp must be assigned first. So next pointer of temp must be assigned first. Must be assigned first means what is first? 0. So here you are placing 0. Means what is the connection? This is not the connection. The connection is this next pointer is pointing towards null because you have assigned first. What is first? 0. So if next is equal to 0, then it is pointing towards null. So that is your step number 4. Now step number 5. Step number 5 is what is there? Brief pointer of first. Brief pointer of first. What is the meaning of this brief pointer of first? Means there should be some double linked list node containing 3 parts. This is brief part, data part, next part, and first is pointing towards this, right? First is pointing towards this. Then you may have the provision that brief if first pointing brief, first pointing next, and first pointing data. But if first is pointing towards nothing, it is pointing towards null, how can you have this provision of fast pointing brief or fast pointing next or fast pointing data? That is invalid. There is no physical entity to which fast is pointing. So there is no question of doing fast pointing brief or fast pointing next or fast pointing data. So then you will face a runtime error, which is step 5, because fast is null. So null pointing brief you are trying to do. So how can you say null pointing brief? Null means nothing. Its pointing brief should be what? Nothing. It will lead us to a runtime error, maybe compilation error or runtime error. Nothing means nothing. Nothing means it does not have any physical entity. That means it will not have any brief pointer part or link part, next pointer part or data part. So this is invalid. Fast pointing brief if fast is equal to null. So you will face a runtime error in this step 5 if the double linked list is empty. Step 6 is fine. First must be assigned temp. So if you successfully do this step 6, the first will be assigned temp. What is temp? 2000. So here you are simply putting 2000, and thereby first is pointing towards this, and this connection is lost. That is fine. Step 6 is fine. Okay. But whenever you are trying to attempt assign a value of temp in fast pointing brief where fast is null, then you are having a problem. And I just want to ask you, is this step 5 at all required when you are going to insert a node at beginning when linked list is empty? Tell me. Is
No, sir, it is not required.
It is not required.
Yes.
এটা তখনই দরকার হতো যখন ফার্স্ট একটা অলরেডি নোডকে পয়েন্ট করে রয়েছে, তখন তার ফার্স্ট পয়েন্টিং কি হবে? So step 5 is required only when the double linked list is empty. Oh,
step 4 তো তাই.
Step 5 is required only when the double linked list is non-empty. If it is empty, step 5 is not at all required. Okay. So this step 5 is extra in case of non-empty case. It should not be, it should be absent in case of emptiness. So now we are in a position to complete our algorithm. Okay, yesterday I couldn't find any time. I was not in a position to talk in this much detail because terrific situation was happened in previous lab class. I don't know what we'll do. B section, B group, group 2 will do tomorrow. I don't know. Okay. So here, if list is empty,
স্যার স্যার আমাদের এই গ্রুপের আগামীকাল ইয়ে করাবেন, মানে ডাবল লিংক লিস্ট করাবেন?
double linked list. Yes.
আচ্ছা।
So all these step 1 to step 6, I'm copying over here. I'm copying over here. and here end if. Only step 5 should not be there. Should be step 5. Let me write it step 6 as it is. Step 5 is not there for your easy understanding. And you know, so if you want to just blindly convert this algorithm into the program code, then step 1 to step 4 you have to write repeatedly inside this if block, also inside if block. So what we can do little bit of code optimization, control X and doing cut paste. It is common to both the if. So why don't we do that before this if block? Step 1, step 2, step 3, let me give a space so for your better understanding. Okay, so this is your step 1, then step 2, step 3, step 4. Then if block is coming, so if list is non-empty, then you are doing step 5 and step 6, then end if. And if your list is empty, then you are doing only step 6. I hope you have understood now.
Yes, sir.
So that is your algorithm. So you know number of lines we have decreased. Okay, step 1 to step 4 common. Before if block we will do this and just check if list is empty or not. And how can, now question is how can we check whether the list is empty or not? So this is just a concept from the scheme.
Sir, if fast double equals to null যদি করি তাহলে
Yes, if fast is equal to null, then we can understand yes the list is
empty.
So let me write this here. Checking if list is okay. If fast equal to null, then list is empty. If fast is not equal to null, then list is non-empty. That's all. By this simple condition checking, you can do this. Algorithm for insertion at beginning in Doubly linked list. So it's already 1:34. So should I take 5 minutes more to show you the program implementation?
Sir, while we are writing the algorithm, we have to write in this manner, stepwise.
This is for your ready reference, for your understanding. Step 1, step 2, like this. Because if you just for easy, first time, but actual algorithm must be written in a better manner.
না স্যার সেটাই বলছিলাম যে ল্যাব ম্যানুয়ালে যখন লিখবো তখন কিভাবে লিখবো সেটাই।
তখন এইভাবে লিখবে না, কিন্তু প্রত্যেকটা জায়গায় আমি কমেন্ট করে করে দিয়েছি, কমেন্ট করেছি।
হ্যাঁ হ্যাঁ।
Because this is not the way we used to write algorithm. Okay. So here maybe so for example this. So here we will write like this, temp pointing towards okay. So that is the new node, newly created node. Okay, that's okay. This much we can write. Oh, you do not want to write the code, malloc falloc that thing. Okay, next, pre pointer of temp must be null. This is straightforward. Temp, we have to write temp pointing pre, otherwise there is no such provision How should I write temp pointing pref? This is the only way. So that's why it is straightforward now. Then temp pointing data data is equal to val. Then this is, but yes, these comments are very important so that you can understand which line is doing what. Temp pointing next is equal to fast. Okay, brief pointing this. So this is means fast pointing brief is equal to temp. Next this temp should be equal to, sorry, fast should be equal to temp. Okay, that's all. This is how we used to write algorithm. But yes, comments are very necessary because you are a beginner. I strongly recommend you write comment. Here also step এটা হয়ে গেল, step 6 হয়ে গেল, step 6 here also fast. Also you can reduce step 6. Step 6 is also I mean common to both the if block. So what we can do, that is further code optimization. Oh, it is not required. That's it. If this, otherwise this, yes. Okay, right. Step 6, where fast equal to this much. This is how you used to write algorithm.
Okay, sir.
And here also you will replace list is empty, means you will write here if
Fast
fast
is equal to null.
equal to null, not double equal to single equal to. Next, if fast equal to, then we will do this. If not empty, list is non empty, so here you will write fast. Here you will write mathematical operator, that mathematical symbol of not equal to. So not null. Okay. I hope this is clear to all of you. Okay, so I think it's already 1:38. I should stop here. I hope that all of you have listened the class. Video lecture
Yes, sir. Yes, sir.
has been recorded. So I don't think after listening the lecture, and if you have missed some point in the lecture, you can always refer the recorded video. So after seeing the lecture and recorded video, I don't think there will be a single person who is not getting understood about the operation insertion at beginning in Doubly. If you feel still uncomfortable, you can always ask in the lab class, or you can ask for a tutorial class. That's all for today. So let me take the attendance. Serial number starts with, okay, let me stop the presentation.